In this video, we will be doing the following problem. Solve for all letter variables in the following figures. So if we look at the figures here, we see we have parallel lines, parallel lines, parallel lines, and then we have transversals on each one, two transversals on each. So what that means is we have equal proportions between the parallel lines. So the proportion of this segment to this segment is the same as the proportion of this segment to that segment, or the proportion of a sum of segments to a sum of segments. And that's true in all of these. So that's how we'll solve it. So here we have the proportion of these two, which is 20 over 15. So 20 over 15 equals the proportion of this whole thing to this whole thing here, which is 5x minus 9 over 27. Then 27 times 20 is 540 equals 15 times 5x is 75x. And then 15 times 9 is 135. So then we have 75x equals 675. And then x equals 9. So let's take this 9 and plug it back in. 5 times 9 is 45 minus 9 is 36. So we have 36 there. Now let's check and make sure we have the proportion as a check. So this original proportion, 20 over 15, 20 over 15 divided by 5 gives us 4 over 3. And then let's do this, 36 over 27. So 36 over 27. So divide each by 9. And again, we get 4 over 3. So we have our check on this one. The proportion of the whole length here and the whole length here is the same as the proportion of this segment to this segment. And now we come over here and it's going to be the same thing. The proportion of this side to this side will be 5 over 7 because we have these two segments here. So then 5 over 7 equals x over 14, x over 14. So then x equals 14. Bringing it up, we have 14 over 7 is 2 times 5 is 10. So that's going to be 10 right there. And you can see if we double 5, we have 10. If we double 7, we have 14. So we have the same proportion. Now we come down here for the y, and you can see the y is these two segments. So this whole thing will be proportional to the sum of these two segments here. So 5 over 7 equals y over 49. So then again, bringing this up, 49 over 7 is 7 times 5 is 35. So y equals 35. So this is 35. Now as a check, let's make sure we have the same proportion. So we have 35 over 49. So 35 over 49, dividing each by 7 gives us 5 over 7. And we have our check. The proportion of this length to this length here is 5 over 7. The proportion of this segment to this segment is also 5 over 7. And that matches our original 5 over 7. So now we come over here to this figure, and you'll notice there's nothing across from the 28. There's nothing across from the 49. And these two longer segments have a variable in one of them. However, what we do have is 44 and 28. And then 44 minus 28 is 16. So now we have 16 over 49 here. So now we can write our equation. 49 over 16 equals 7x plus 14 over 44. And now rearranging, we get 2156 equals 112x plus 224. And then moving this over, we get 1932 equals 112x. And from there, x equals 69 over 4. And as tends to happen when you don't have an integer solution for a variable, people get nervous. But let's try it. Let's plug it back in. So bringing this back over here, we have 7 times 69 over 4 plus 14. And this product will be 483 over 4 plus 14, which is then 539 over 4. So now we're going to divide this by 44. And to make it easier to see, we'll show it as 539 over 4 times 1 over 44. And then doing the math on here, we get 49 over 16, which is this original proportion. And to test taking note on these, as always, when you do not get an integer value for your variable, it doesn't mean you're wrong. Plug it back in, see if it works. In this case, it does, and then you can move on. So that is our summary of parallel lines with two transversals and how the proportions work. As always, do these problems 2 or 3 times, conquer it, and then you can move on.